All right, since we're all ready, let's see. So, class.
Yes.
Okay, all right. So, we are going to get to this point right here. 2 more examples left, and we'll finish this up. 4? 3.
4.3.
Yeah, 4.3. All right, so we're going to go through and find all points of inflection. Points of inflection is when my second derivative is equal to 0. So, first derivative, I'm going to get that y prime is going to be equal to, how about this? Let's rewrite it first. So 2e negative 2, I'm sorry, negative
X squared.
x squared. There we go. All right, let's u this. So u, in this case, would be,
E to the, no.
how about x squared? I could do negative 2, but, so u prime would be 2x, right?
Yes.
Okay, so I'm going to rewrite it as 2e to the negative u. And the derivative is going to give me, very good, so it's negative 2e negative u times u prime, which is 2x.
Okay.
Okay, then put it back. So it's going to be negative 2e to the negative
X squared.
x squared times 2x. So I can put all those back together. So it's going to be a negative 4x e to the negative x squared. That's my first derivative, right? That's my first derivative. And second derivative is going to have,
Second derivative is,
very good, yes, it is a product rule. Second derivative is going to be a product rule. So, rewrite it as y prime is equal to negative 4x e to the negative x squared. So I'm going to do my u again, but before I do that, I have my f and I have my g. So f prime is going to be negative 4. G is going to be the,
it's like Fy. It's like the first one.
so like this. What I'm going to do is I'm going to do the u sub again, right? So it's a chain. So I could do it again. So isn't that what I started off with? Kind of, right?
Kinda, yeah.
It's just I don't have the 2 out front.
Yeah.
So if I didn't have the 2 out front, then that means I would only have, what would my answer be?
It would just be like 2x e to the negative.
Yeah, so 2xe negative x squared, right? All right, we'll do it. So so let's see, the u is x squared, u prime is 2x, and then I'm going to have e to the u, negative u, so that's going to be negative e to the negative u times u prime, so negative e negative x squared times 2x, so that's going to give me my g prime is going to give me a negative 2x e to the negative x squared. Does that make sense, or am I going crazy? All I'm doing is setting up the product because I have to have my F prime and I have to have my G prime, but my G happen to have a chain rule in it. So I slowly put it all together. Now I can actually just do the product rule just by plugging everything into the product rule. So if I plug it into the product rule, so it's F prime G, so it's going to give me negative 4 times G, which is e to the negative x squared, plus G prime, which is going to be all this, which is negative 2x e to the negative x squared times f, which is going to be my negative 4x. Let's take out common factors. Okay, what's going to be a common factor here? This is going to make my life easier also.
Negative 4.
I have a negative 4. What else can I take out?
E?
Yep. I could take out one of those e's, right?
Yeah.
So e negative x squared. So if that's a common factor, did I take out everything there?
Yeah.
I took out everything there. So if I take out everything, what's left?
Negative 2x.
If I take out all that, it's 1.
Okay.
Okay? And then over here, I have a negative and negative together, but I just took out one of those negatives, right?
Yeah.
If I took out one of those negatives, I still have one negative left, right?
Yeah.
So this is going to become a minus sign. And what else am I going to be left with? 2 x
and then there's another x.
Squared. There we go.
Oh,
Okay, I'm going to have negative 2x squared. Because I wasn't able to take out an x over here on that side, so I couldn't factor out that. So close that up. So this is going to be my second derivative. So this is my y double prime. Actually, that one was too, but I'm going to simplify it like this by factoring it, and then it comes out like this. It's going to make my math a whole lot easier too by factoring it. So when I factor this, I need to know that I'm looking for inflection points, so that means my second derivative equals a 0. So I'm going to take away my y double prime, and I'm going to put a 0. Okay, I'm going to take that away, I'm going to put 0. And using 0 product rule, since this is multiplying by this, if either one of these, that's the reason why I factored, if either one of these is going to be equal to 0, then the whole thing equals 0, right?
yeah.
So I could separate it using this. Equals negative 4e to the negative x squared. We'll have 0 equals 1 minus 2x squared. With that negative exponent, what can I do with that negative exponent? What do you think? Yes, but if I turn it into a fraction, be specific. What do I do with it?
Move it down.
Move it down. Move it to the bottom. So that would actually make it a little bit easier to see this. So 0 equals negative 4 over e to the positive x squared. Now there's certain things I should know. What am I not allowed to have in my denominator? I'm allowed to have irrational.
Oh, okay.
not allowed to have radicals, but I don't have a radical here. Only Chuck Norris could do it. Divide by 0. See?
Okay.
One person gets it. Divide by 0. So I can't divide by 0. Now, would this right here, so if I plug in 0 for my x, 0 squared, what is e to the 0? 1. Anything to the 0 power is 1. So, being what this is right here, is there any way to make this into a 0 in my denominator?
Any way to make it a 0 denominator? No.
Can't do that. Nope, it's not going to. I can't make it into 0 because even if I plug in a 0, I would still get 1. If I plug in negative numbers, okay,
Become positive.
it's going to become positive, so it's still not going to happen. So right here, because that's where my variable is, I'm going to show you, because right here it's can't be equal to 0. So watch this. So from here, if I'm going to try and clear out my fraction, okay, my variable's down here, right? What would I do to both sides to get this out of a fraction?
Multiply it by the denominator.
Multiply both sides by the denominator. But when you multiply everything by,
0.
yep,
Cancels out.
so this all goes away, so I end up with 0 is negative 4.
Which
Is
not
that,
true?
yeah, so it's not true. So that right there is not going to be part of my answer. That is an erroneous, it doesn't work out. There is no solution there, so that doesn't work. But on the other one, let's see. Subtract, actually let's add 2x to both sides. Or my 2x squared. So I get 2x squared is equal to 1, right?
Yeah, just give me a second.
And then divide by 2, I get x squared is equal to 1/2. And then square root both sides. X equals, yeah, plus or minus 1 over radical 2, but I can't leave it like that. Can't leave it like that, can't have a radical in denominator. So multiply top and bottom by rad 2, right?
No.
And so rad 2 over rad 2, by rationalizing I get rad 2 over 2. So it's both plus and minus rad 2 over 2. Now, all this work right here to get these two numbers. Now, what do these two numbers give me though?
Wait. What did they give you?
Yeah, what did we solve for? We did all this for a reason.
Those points. It's like you're.
Points of inflection. So my second derivative is going to give me my inflection point. So like she's doing right there, throwing up those gang signs, right? Throwing up the gang signs, it's where my thumb and my pointer go together, right? Thumb and pointer go together. That's the point where it's changing it from concave up to concave down. Does that make sense? Yeah?
Yeah.
Hopefully? Okay. So yeah, so that changes concavity right there. So those are the two answers that I'm going to get. So I have my points of inflection here. That's what I'm looking for. Does that make sense, Danny? Okay. Alrighty. So, now the second derivative test for local extrema. This is, you take your first derivative, set it equal to 0. That's going to give you either min, max, or something, right? That's going to be where my slope becomes 0. So it's going to be a min or max somewhere in between. Now, you take that same point and plug it into the second derivative. If my second derivative is less than 0, it has a maximum. If my second derivative is greater than 0, it has a minimum. So hopefully you guys feel pretty good about this. So we get the first derivative equals 0, and then plug that number into the second derivative. All right, so let's go first derivative. This is going to give me 3, my f prime of x equal 3x squared minus 6. That's my first derivative, right?
Yes.
Okay, set my first derivative equals 0. So I get 0 equals 3x squared minus 6. Add 6 to both sides, I get 6 equals 3x squared. Divide by 3, 2 equals x squared. Square root both sides, x equals plus or minus radical 2. So there is where my first derivative is equal to 0. So those are going to be local min, local max, one of those, okay? So, or neither if it just keeps going up in the same way. It's just where my slope becomes 0. And now let's go the second derivative. So my second derivative, so f double prime of x is 6x. Right? Okay. So, according to the derivative test, I just need to plug in my values that I had for my first. So let's see. So it's f double prime of positive rad 2 is going to give me 6 rad 2. According to the test, when I plug it in, if it is greater than 0, then I have a local minimum. So I have a minimum there because these numbers are positive. Do it again. F double prime of negative rad 2 is going to give me a negative 6 rad 2. And according to the second derivative test, that means I'm going to have a maximum. Is that pretty easy now? So we talked about a lot. Yes, you know, it's just getting the math to get to that point.
I think my only confusion is that I was just thinking of over the things are where it's like less than 0. I would just
So the whole thing has to do with concavity, and so if it's a maximum, it's like this, right?
so it has to point down for
Yeah, so if it's maximum, it's negative. So that means I have it's a negative parabola, right? It's a negative parabola. So the x squared is going to be upside down. So that means that right there, it's going to be a concave down, and that gives me a maximum. Okay, same thing go for the minimum. So minimum is concave up. So I have a positive number opening up. So my concavity is positive, and so that gives me a minimum there.
Yeah.
Does that make better sense? Throw up those gang signs. Okay, so for this right here, this is actually just a whole bunch of different examples of the types of graphs that you can see and what you could look at from this. So this is differentiable smooth connected graph, may rise and fall. Right, this one where my slope is greater than 0, everywhere it rises from the left to right. Okay, graph is less than 0, so y prime is less than 0, so it's going to fall, it's going to keep going. Now right here, this is going to be y double prime is greater than 0, so it's concave up. On both sides, it's going to be concave up on this one. Okay, this one is y double prime is less than 0, so this is going to give me concave down on both sides. Right here, this is going to be where it changes sign. This is where it is a concave up and then a concave down. That's my point of inflection right there in between my two fingers. Right here, y prime, So the slope changes. So right here, this is goes up to a 0. So if it goes from a positive to 0 to negative, that is going to be a maximum. If it goes negative to a 0 to a positive, that's going to be my minimum. Okay, if y prime is equal to 0 right there, y double prime is going to be less than 0. That one is going to give me that it is going to be my maximum. That's what I was talking about. The gating signs. Y prime is equal to 0 here. Double prime is greater than 0, so that one's going to be my minimum. So, yes, good. So make sure you guys all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff at the merch store. Denny, you were supposed to buy something. Okay? All right. So work on the assignment, please. You should be able to finish it up today.